we have discovered that the real polymers, the real polyesters, are produced in nature.
I know that the process from the point of view of environmental impact is impeccable.
The mechanism of polymerization is operated by a biological source, by bacteria.
There is an effective capacity to bring this thing here, to be a true, consistent answer to a series of needs.
Thus, still today, incredibly, with respect to our efforts and how much we have researched this, there is no solution. A world without plastic is absolutely impossible for us to imagine. The history of innovation is a story of small groups or few people.
We will do everything to make sure that Bio-On is the next big result of Italian genius.
It's called plastic, but it's not the plastic that people know. It's something else. It almost needs another name.
Plastic, plastic, plastic. What are plastics? Are they vegetable or mineral? Perhaps they are in the sea. Are they a gift of nature or an invention of man's?
Plastic could be a wonderful material if you use it in a more sensible manner. Light and economical, plastic has literally invaded the world. The result of this uncontrolled use is that the world is full of plastic waste that we no longer know how to dispose of. The answer has been found by two courageous entrepreneurs from Bologna, Marco Astori and Guy Cicognani. Marco and Guy had a microchip company. One of their clients produced ski pass and laid down a challenge to invent a ski pass which, if abandoned in the snow, did not remain there after the thaw. The two entrepreneurs took up the challenge, and between the United States and the beet fields in the Bolognese countryside, discovered PHA, an incredible natural material. Marco and Guy thus founded Bio-On.
Before putting the final touches on this new adventure, I really enjoyed looking into new things to develop in various types of sectors.
The adventure consists in having an intuition and seeking to transform this intuition into a business. Marco had this vision of the ski fields being invaded by plastic carts, and thus thought that if the plastic then dissolved into the ground, this terrible result could well be avoided.
To find a new material, a material for making these ski passes in a way that they are neither paper nor plastic, and thus to carry out research aimed at finding a different material, which did not exist.
The two partners took up the challenge because they had the intuition that whoever could solve the problem of the biodegradability of plastic would have transformed the world.
To make a type of plastic that had no constraints, neither structural, physical, mechanical, and which would be in every way equal to that made by petroleum.
Marco and Guy closed themselves in the office for 7 months and study everything that they're able to find on the net regarding the world of bioplastics. The answer seems to lie in PHA, a natural material apparently in all respects equal to plastics in common use. Not petroleum-based, but instead produced by a good bacteria which feeds on food waste.
We watched and studied all the solutions and all the companies which had set up to make biopolymers. And we had our particular list of things which we had seen, which had been developed by others, which we didn't like. And from there, all our research began, which bore good fruit, because we found all around the world people who in the preceding 10 years had developed ideas or parts of ideas, which later became patents, and we immediately purchased them, and we sought out people who had the experience to create that which hitherto was only on paper, and we built everything from scratch.
Having said that, in a fantastically imprendatorial way, he took a plane, presented himself with a lawyer and a check to his university, and simply basing himself on a dream and an idea, he went and secured the exclusive rights of use for this bacterium.
It is not so difficult to buy a patent. It's very difficult to acquire a patent and then demonstrate that through that patent there has been created a product, or that one is capable of creating a system which manufactures a product or an application.
Bioplastics are not new. Many researchers and many companies have embarked on this adventure, but often to produce a plastic which is biodegradable, one must use raw material of considerable value, which could be used for other purposes. No bioplastic which could really be scrapped, such as PHA,
The result is that today there are bioplastics, as we talk of biofuels. Then let's make plastic from corn. But we've got to be crazy to think that we're going to use, to make a chair, a toothbrush, or a bowl with something that we could eat instead.
The polydrosylcanoate, or PHA, is not a recent discovery, but its existence was discovered by a French researcher in the 20s and then practically forgotten. This is a plastic material, a polymer produced by a bacterium that feeds on the waste produced by the working of sugar beet. PHA is a completely natural product and completely biodegradable, because the same good bacteria that produce it, once re-released into the environment, reabsorb it.
It is a product, a polydrosylcanoate, extremely flexible and clear, so you can make it into films. That is very thin plastic, to important and very large objects, which have great resistance. It is a bioplastic, a plastic made of living organisms, that is, bacteria, and then afterwards recovered in the environment by the same bacteria.
The PHA could perhaps change the world, transforming waste into objects necessary for our life.
The whole process begins here, with a few bacterial cells. We take the bacterial cells and we place them in a flask. And when I see that there are sufficient numbers, I put them into a fermenter, and in the fermenter I begin to feed them. The bacteria feed on carbon sources. The carbon sources I can find in diverse elements in nature. We find them in discarded material. We saw that there is an important source of waste in the production of sugar beets, and we used that.
The source of food waste. No competition with the food chains. That which would become costly waste and difficult to manage and dispose of by the production process becomes prime material.
It is an almost inexhaustible source of raw materials to produce biopolymers. At the end of the process, the cells of the bacteria are full of the powder of bioplastic. We transfer the material to the recovery and purification in order to destroy the cell, eliminate that which is not PHA, and obtain, in pure aqueous suspension, the PHA. Then from a completely dry powder, they are then extruded, transformed into pellets, which from there are transformed into objects.
A few months ago, Piero Gandini, the president of Flos, one of the most important producers of designer lamps in the world, read an article on Bio-On and on their revolutionary work. Gandini, always on the lookout for new avant-garde materials, was very curious. The types of plastic, recycled plastic, plastic from maize, those things here we've seen, but we've never found the right answer, in the sense that they are plastic which, over and above the experience, as it were, in principle, for those who make use of them, to be created, use up a lot of resources in the process, because they use a great deal of water. They don't begin as waste, and thus it's true that they are bio, but they are catastrophic from the point of view of environmental impact, and on the other hand, don't have the minimum use.
And we go and use up entire maize fields, or I don't know what else, simply to make objects which we could then no longer eat. It is a consequence so serious that I think that people who propose it should be treated almost as criminals against humanity.
I don't believe that things have a meaning in just saying they're green, and then in reality behind all this there is no effective consistency. This is why I threw out the challenge to Marco and his boys. If a magazine like Wired gives it 10 pages, maybe there's something to it. And Marco and Guy came into my office and told me of their adventure. At a certain point, I said to myself that I haven't got before me the usual green preachers who are looking to resolve their karma, telling you a few things and then coming up with nothing consistent. So I fleshed them out and I said to them, are you able to develop a real product with this thing here? And they looked at me and they said, well, who knows, but we believe that we can.
He immediately asked us to do something really difficult, which was that of reproducing the polycarbonate performance with which Miss Sissy was created, a lamp designed by Stark. At first response, we gave a negative impression because we had never thought that our bacteria could produce a type of product such as polycarbonate.
They wanted to revolutionize the world of plastic. We, by means of a plastic object 20 years ago, revolutionized the world of design with Philippe Starck. We created this object, which was a political operation, when it came out in '91.
The big challenge was, within 3 months, to feed the injection molding machine that had always been used for the creation of Miss Sissy in polycarbonate, which is the commercial lamp, keeping the mold constant, the press, and thus the machinery, where there was no time for modifications, seeking, in fact, to have a granule in time to make the lamp.
Here was the precise objective to go and substitute a known product with a noted design made by a very famous designer to test our skills. This was for us the mission of BioOn.
So for BioOn, I had to launch this challenge, a bit for its symbolic aspect and a bit for the technical aspect. This lamp is in polycarbonate, and polycarbonate is a polymer which has, however, elastic mechanical properties and resistance to temperature, fire resistance, and thus is a technical material, in inverted commas. And they had to be able to reproduce these qualities. Piero Gandini issued a challenge to Marco and Guy: construct a real concrete and tangible object with PHA.
Not only exactly using the same press, with the same parts, the same life profiles, exactly the same machine, we succeeded in obtaining the parts which constituted the lamp Miss Sissy, with a short process time, shorter than that of polycarbonate, and, above all, with a minor use of energy.
Six months after, they arrived with this. And I was a little stunned. And so I said to them, is this it? And they said, not totally, in the sense that the transparencies, the colors, some mechanical aspects still have to be perfected. But in fact, your Miss Sissy, in only 6 months, here it is.
People met who had just ideas and enthusiasm. He to put something new, such as materials in the world of design, and we to seek to reach performances of materials which we saw as almost unreachable.
Philippe Starck was enthusiastic. Philippe Starck, when I showed it to him, he said to me, but what is that stuff? When I explained how the process worked, he said to me, Piero, when you're ready to start planning seriously, let me know, because I don't want to miss it. Marco leaves a lot of freedom to everyone, the freedom of research which he gave to the scientists who work for him. And this has been, according to me, essential in generating the results which the scientists have brought about. And this is a bit like a pool where the scientist wallows happily and thus produces notable results.
The company has grown in terms of employees, but above all, it's been able to demonstrate that a patent, which is a piece of paper, can be transformed into a productive process and into a plant.
Is true innovation the result of magic or a process? Well, the truth is the result of a combination of magic and process, and the difficulties that the magicians and the engineers find it hard to agree upon. Marco, Guy, and all the collaborators of BioOn have demonstrated that it is possible to transform a dream into something concrete and tangible. The challenge of Miss Sissy is the demonstration that PHA can give incredible results. Now the next step is to become big and build a real production plant. It is a challenge which is even greater, and the investments are enormous. BioOn collaborated with Techint, one of the largest engineering companies in the world, which let itself be influenced by the dream of Marco and Guy. We had some reports that BioOn was looking for a partner such as Techint. In fact, a partner capable of constructing plants to give them a hand in this first phase to bring the plant to the state of pilot project for an industrial plant. And most of all, then, in a second phase, to have the capacity and the strength to realize plants, to sell them on the market, and which would thus then have a dimension which I would describe as international, which is now what we are. The effort of a manager, which I tried to be, is to create a climate of agreement between magician and engineer. In this case, between Marco, who is a magician in some way, a dreamer, and with the engineers. And we put him into the Techint company, which is clearly the quintessence of engineering. And with some difficulty, however, the combination worked. Techint took in the dream, and thus began to work with an energy which appears disproportional to the size of the project, which now we have in hand because it believed in the dream of Marco. The thing that, if you like, interested and fascinated us most was the quality and the typology of the technology which BioOn developed. Thus, today it is a world in evolution. So we must begin rapidly. We must pay attention to how this market evolves, and we must be prepared to address both the project as such, but also the project according to the type of customer that we have before us. Marco, in some way, has limited the extent of his dreams, because now, ranging from medical to automotive, from aeronautic to missilistic, Marco has in mind to be able to do everything with this project, and has sought to concentrate on certain elements which allow Techint to build on this, above all, an industry. BioOn is also planning its first factory, a building with soft and revolutionary form, which has to integrate with the environment and be the least intrusive as possible.
They told us this story of this initiative and desired that the building be up to the job, a building rich in design and originality. When Marco and Guy saw the project, it in fact resembled this bacterium, which is at the basis of all the fermentive process.
Beginning with nature, they recreate the synthetic material par excellence, but also aim to give the work the right weight in our lives. These are the stimuli which animate Marco and Guy in their challenge to create bioplastic, which could transform the world.
From the fields to the modern art museums. This is very interesting, very lovely. One of our objectives is that of seeking to work the right quantity in the right amount of time. You have to make an effort to try to work less, the right amount of work to obtain the most efficient results. This you can do, in fact, with clear objectives and removing things to do, rather than continually adding to them.
We may hypothesize that Biowan will become a hallmark for the final customer. I always think of the computers which have Intel written inside, which become a hallmark for the performance of the computer. In the same way, with Biowan inside a bottle, Biowan will become the guarantee trademark that this bottle does not harm the environment.
To be small and try to compete with the big guys, having few available resources. It is not a game, and it is not a trivial challenge. There are many people who are trying to change a certain type of chemical, making it become the friend of mankind.